Good morning. So part two. So we said we were going to have a little bit of a look at a dangerous project. So I'm not going to tell you what it is. You can see at the end if it works, if I've blown my fingers off or I've set the house on fire. But nevertheless, we will give it a go now. So first off, we really need to take these. Unfortunately, I haven't got any coat hangers that aren't painted. Of course, in the good old days, these wouldn't have been covered in some nasty paint. But we need to get these as straight as we can. Might have to get them in the vise and give them a bit of a wallop with a hammer. But what I basically want is a long metal rod that is as straight as I can get it. So now these are pretty much as straight as I'm going to get them for the minute, and these are 2.1 mil, so we'll see how that works. I'll probably be able to find out what sort of current that will draw, put up with at some point, but it's got to put up with some heat as well. So what we need to do is then fashion ourselves two electrodes. Now, of course, if I want these to conduct any sort of energy, having them insulated all the way up might cause a problem. So we will need to burn all of that off. Now we've burnt all of that off, we need to give it a bit of a clean. Right, in between all the noises of the house and the continuity mess ups, I'm going to screw all this together, but to save you having to watch that in real time, I'm going to speed it up. Okay, for those of you who haven't guessed yet, we're building a Jacob's ladder. I would stress this is not a informational video. I'm not explaining how you should do it. If you can't work it out and you don't have the competence, you haven't done the research going into this, then best leave it alone. So we have a 10,000 volt neon sign transformer connected into two electrodes. The idea is the gap is small enough at the bottom for the arc to start, but it's not so small that it stays there. The air heats up between the gap, starts to carbonise the air, and then the arc will spread out and break off somewhere up here. 10,000 volts in theory should be able to jump 2 inches easily, so we might expect to see with a with carbonised air that this might raise all the way up to the top of this electrode. It's quite long, so it might not. It looks longer than it is actually. I haven't measured it, but anyway, I think the next part of this, we may well take this outside so I can turn this on from a safe distance. Be back in a minute. Right, let's have a first attempt. Ah, now there's an interesting phenomenon for you. Can we see that? That is arcing out straight between the blocks. Look at that. So here we have carbon treeing across the Bakelite. An unexpected effect, but something else I wanted to talk about at a later date. So this is very interesting. That is jumping 25mm without any issue, and getting easier and easier for it because that's cooking the Bakelite, creating a carbon track. So that is, I don't want to get too close because it will hurt if it jumps to me. But there you go. That's a carbon tree growing across an electrical connection. So that bit didn't work, so I've got to revise that. But the smell of burning Bakelite is brilliant. There we go. Carbon tree growing across a Bakelite junction box. Brilliant. Okay, so we've retired back to the workshop to build a version 2. We've got a bit more gap. We've got some brass terminals. We've got 11,000 volt insulated mat between. Hopefully that will sort that out. Still not certain about this cheap Chinese neon sign transformer, but hey, not going to spend a load of money only to find I can't do it. So we discovered we can make this, which is a carbonisation between two terminals, and this is very similar to what you would see in a loft where there's been dust, damp, and it will eventually track out, and you will get a call out, and you'll find something very similar to that, which shows that all your creepage distances and your insulation separation is fine while it's clean and tidy, but as soon as you start getting damp and other contaminants in there, then you're going to get problems. So back to what we were playing with. We've had another go with this. Those are too tall, we're not going to get that high, but anyway, so if we turn this on, we get the initial spark at the bottom, and then that carbonises the air, reducing the insulation of the air and causing an arc. If you've ever watched high voltage power lines in the rain, you'll see these tracking down the insulators. If you've ever been around open air substations where they use air as an insulation, you can see arcing and sparking, especially when they're switching. You get massive great arcs because it's air insulated and they have to allow enough space to get the arc to clear. So while this isn't as good as I would like it, that's certainly not pretty, but it goes to prove that you can make an arc jump what is now probably 10mm and expand that out certainly to 50mm, and with something a bit bigger than this transformer you wouldn't have to increase the voltage, you'd have to increase the power that it develops, and you'd get that to jump a lot better. But anyway, so there you go, Jacob's ladder on a Sunday morning, because I can. Thank you. By the way, stay safe, that is 10,000 volts, it will hurt if you touch it. I'm standing well away, watching it crackle and bump around. Actually, if I was going to take this anywhere and show somebody, I might like to put it in a Perspex tube or something just to insulate it all away. But yeah, great. Had fun with that, and look forward to doing a bit more on trucking, creeping distances, and what contamination can do to your insulation. Thank you very much, and especially today, stay safe.